Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we would talk about BGP attributes, specifically we would talk about origin. Now as you know that origin is a well-known mandatory attribute, it must be present in the BGP update. There are two different types of BGP origin attributes. We have the IGP, which is I, and then we have the incomplete, which is question mark. We also have the EGP, which is no more supported by Cisco devices. So the only two types of origin codes that you can set your routers to be would be IGP, which is I again, and incomplete. So if you advertise a network using the network statement, automatically your router would assign the origin code as I, and if you redistribute the route in BGP, then the route would be tagged or the origin would be set as incomplete. So this attribute is basically well known and mandatory. It must be present in the update. What does that mean? It basically means that it is transitive. It can be sent across from one AS to another AS. It is transitive. So to look at this origin as a path manipulation attribute, what we would do is we would look at this diagram here. I have three routers in AS1, and I have router 4, which is in AS2, router 5, which is in AS3, and router 6, which is in AS4. All these routers have been pre-configured with BGP. So I have a neighbor between 1 and 2, 2 and 4, 4 and 5, 5 and 6, 3 and 6, and 1 and 2. 2 and 3 are not iBGP neighbors. Besides that, internally I am running OSPF here. So router 2 and router 3, they have reachability to each other through OSPF. R1 has also been pre-configured as a route reflector. So R1 is going to give routes learned from R2 to R3 and routes learned from R3 to R2. Now, as of right now, if I look at from perspective of this route, R5 is advertising 5.5.5.5 in BGP, and he is advertising that using the network statement. So how should all the routers see that route? They would see that route as IGP, which means I, if you do a show IP BGP. Let's in fact quickly verify that first. So if I look back at R5's configuration, you would see that, let me in fact show you the show run section router BGP. You would see that I am advertising 5555 using the network statement, which means that when R5 advertises that route, he will insert the origin code as I, which basically means IGP. So show IP BGP shows you your origin code, which is going to be I for IGP. If I look at any other router and do a show IP BGP, you can see your origin code, which was set by R5, and you can see the origin code is I. If I go back to maybe R5 and remove the network statement, and instead of me giving network, I redistribute the route, in that case, the route would be seen as incomplete. Let's try this out. So router BGP 3, router BGP 3, and let's remove the network statement for maybe 55. And let's give redistribute connected. You would see that when R5 advertises the route, this time for the network 55, he would not send the origin code as I, instead he would set it as incomplete. So show IP BGP should show me that. Let's go back and check. So I do have the route now 55, 55, 55, 55, and if you look at the origin code, it is now showing as incomplete because I have redistributed that route. Which one is preferred in origin? Is I preferred or is incomplete preferred? Well, if all the previous attributes like wait, local preference, your AS path, if they all are the same, and if origin was the deciding factor, then IGP, which is I, wins over incomplete. So let's go to my diagram. How do you think, looking at this diagram based on my BGP neighborship without me making any changes, how do you think router 2 must be going to this destination, which is 5555? If R2 has to reach this network, he has two choices, right? He could go to R4 or he could go to R1. Let's look at the attributes. For R2, we didn't configure wait. We have not made any changes to local preference. That's still the same. AS path, if R2 goes through R4, it is 2 hops away. If R2 goes through R1, it is still 2 hops away. So AS path is also the same. Remember, AS path is a hop of AS, not hop of routers. So the AS path is same. Next, it will compare origin. Both the neighbors, router 1 is sending him I, and R4 is sending him I, because we never changed the origin code. R5 is setting it as I, so everybody sees it as I. So origin code is the same. We did not configure MED. Default is 0, which means the next criteria would be eBGP preferred over iBGP. So R2 would probably select R4 based on eBGP over iBGP. R3, which is an XR router, he would also prefer R6 over R1 because of eBGP over iBGP. From R1's perspective, we didn't configure any wait. We didn't configure local preference. For him, the AS path hop count is the same if he goes from R2 or R3. AS path is the same. Origin code we did not change. Default is I because R5 is sending it as I. And MED we did not configure. So for R1, they both are iBGP neighbors, R2 and R3. So what's next? Router ID. Router ID of R2 is lower than R3, so R1 should be preferring R2 at this point of time. This should be my default setting. Let's go and verify this. I would go to router 1 and let's do a show IP BGP. As you can see, for 5555, I am going to R2. R2 is the best choice. If I look at router 2, show IP BGP, for 5555, he is going through eBGP, which is R4. And if I look at XR3, show BGP IPv4 unicast, for 5555, I'm preferring the eBGP through R6. Now, this is my default settings. Now, what if I ask you that I need that the entire AS, which is AS1, they all should go from R2. They should exit out from R2 to reach the destination 5555, which means R3 should not go to R6, he should go to R1, and R1 should go to R2, and R2 should go to R4. For doing this, the only router that I need to change the origin code would be on the XR router, which is R3. As you know that I is preferred over incomplete. If I go to R3 and here if I change it to incomplete, what's going to happen? For R3, now he receives I from R1 and he's receiving incomplete from R6. Can I do outbound origin setting? Yes, I could configure R6 and send an origin of incomplete to XR3. I could do that because origin is transitive. Or I could configure the XR inbound. When I receive the update from R6, I would change the origin code to incomplete, which basically affects its own routing table. So automatically he would now go through router 1. Let's try this out. So I would now go to my XR router. So I have my XR3 router. Let's go and create a route policy. Route policy maybe from R6. It says that a route policy already exists. So let's go and verify what's in the route policy. Show run route policy from R6. So I have some policy pre-configured right now, which is basically prepending that route. Let's go and create a new policy. I would not be able to edit this route policy. If you look at the message that I got earlier, it says reconfiguring it will replace the current definition. So if you want this to remain and also maybe another policy, another rule to be there, you'll have to basically edit the whole thing, you'd recreate the whole thing. Because if you just edit the same one, it's just going to override. So what I'm going to do is create a route policy from R6. And let's put a condition. If destination includes 5.5.5.5/32, then what should I do? I need to set the origin code. So set the origin as incomplete. Else, pass. Let's do an endif and end policy. So what I've literally done right now is I have basically replaced my route policy. My previous prepend is gone. If I look at my route policy now, it's basically replaced with the config that I just did. My previous settings is basically gone. So be careful when you create route policies. If you want to modify it, you'd really have to do the whole thing again. So maybe I'll have multiple conditions that if this is this, then do this, else maybe do pass, or I could have another condition of if inside that, if it is this, then do this. So I could have multiple if conditions inside my route policy. Right now, it doesn't really matter because I'm only looking at origin code for this task, so it doesn't really matter even if I replace it. But be careful in the lab exam, you don't want to replace it if something is pre-configured. So go and recreate the whole thing. What I would suggest is use a notepad in the lab. It really helps a lot. It saves a lot of time in the lab exam. You should try and use notepad. So I think we have already applied the origin to my BGP. So if I look back at showrun router BGP, I have from R6 inbound applied from R6, which basically means that when I receive the route from R6, I will modify my route. So even though R6 is sending an I as the origin code, but when I receive it, I will modify it to incomplete and then put it in my BGP table, which basically means that my BGP table would show as incomplete, and now XR3 should choose R1 because R1 is still sending him I from which he received from R2, and R2 received from 4, and 4 received from 5. Let's verify this. So if I look at 5555, now I am preferring IBGP because this is I versus incomplete. So you see, by me modifying my origin code as the path selection attribute, I made XR3 go through IBGP instead of eBGP by changing it to incomplete. Obviously, your previous attributes need to be the same, otherwise origin would never be the deciding factor. Same thing can also be done for iOS XZ routers, for example, R2. If I look at R2's perspective, R2 is pretty much the same. So if I look at, let's say maybe a route 5555, I am receiving it as incomplete, right? If I wanted, I could maybe change this to be I so that traffic from R2 goes through XR3 to reach that destination. Doing this on an iOS XZ is pretty straightforward. You would just create an access list that matches the route, create a route map that matches the prefix, so the access list basically, and then we set the origin as I or incomplete depending on where you want or which path you want him to take. So let's try this for a network. Maybe we can try this for, let's go and create a new loopback on R5. So interface loopback 15, IP address 15, 15, 15, 15, 255, 255, 2550. And let's go and advertise this route in BGP. So network 15, 15, 15, 15, mask 255, 255, 255, 255. If I look back at R2 now, he should see 15 network in his routing table, and it should not be incomplete. It should be I because I've given the network statement. Let's wait till it changes. Because I had the redistribute statement earlier, so it must have learned the route as incomplete, but it should change in a few minutes, maybe a few seconds more. You can always do a clear IP BGP star soft. And let's check. Let's go back to 5 and do a clear IP BGP star soft. So he resends it. So I'm still seeing it as incomplete. The only reason you're seeing it as incomplete, because if you look at the routing table, what did we give in BGP? We gave the network statement as 15, 15, 15, 15 / 32. What was my subnet mask on the interface? Whenever you use a network statement, it must be exactly as per the routing table. Let's go back to 5 and check my interface loopback 15. I see it as /24. So obviously the route is not being sent using a network statement, it is being sent as redistribute statement. Let's go back and modify my loopback to be a /32. Now on R2 I should see it as IGP, which I can see, which I should see once I get the route. Let's wait till it advertises. BGP is extremely slow as far as convergence is concerned. So now I have the route being learned, which is 15, 15, 15, 15. And if you look at the origin code, it is I. So how is R2 going to this destination? R2 is going straight to R4. How is R3 going? R3 is going straight to R6. And R1 is going through R2. So can I make R2 go through R3? Let's try this with origin code. Maybe I create an access list. Access list 15, permit 15, 15, 15, 15. Create a route map. Let's first check if there is a route map attached to my neighbor. So I already have a route map attached to my neighbor. I do have a route map. You can only apply one route map at any given point of time. So I need to append to this route map. Let's go back and check my route map. So I have some AS path prepending. Maybe I could just create a new sequence number 20, which matches IP address 15, and I'll set the origin code as incomplete. So basically my route map changes to, if it matches access list 15, change it to incomplete. And I've already applied this inbound coming from R4, which means when R2 receives the update from R4, he would check for the route map, change the origin code, and then insert in the BGP table. Let's go and check, show IP BGP. So 15, 15, or in fact, yes, 15, 15. He is going from iBGP because iBGP is I, and eBGP is incomplete. So you see now what's happened is for the network 5.5.5.5, we made R3 go from R1 to reach this network here. And for the network 15.15.15.15, we made traffic flow from R2 towards R1, which was in the direction of 2 to 1 to 3 to 6 to 5 to 4. So I made the traffic go in the reverse direction because of origin. Just remember that I is preferred over incomplete. But origin would only work if your previous attributes are the same. I hope this video was informative to you, and thank you for viewing.